So at this point, it's quite a good idea to just have a quick quiz to see how we're getting on with moles in solution. So here are some questions for you to have a go at, with a reminder of the equations that you're going to need. So those are the equations, here are the questions. So it's a good idea if you could spend a few minutes just working your way through these before we go through the answers. So there's a few, 4 questions there. Get a little bit more difficult as we go through, and you will also need to remember how you convert grams into moles and also volumes of gases into moles. Right, so the answers are coming up, so let's crack on. Question 1, we're going to calculate the number of moles in 5 centimetres cubed of a 0.01 mole per decimeter cube solution of sodium hydroxide. So first of all, we need to find the correct equation, which is number of moles is concentration times volume. We then pop the numbers in, but remember that our 5 centimetres cubes needs to be converted into decimeters cubed by divided by 1,000, and that gives us 5 times 10 to the minus 5 moles. So we're now going to calculate the concentration of a solution that contains 1.05 grams of sodium hydroxide dissolved in 500 centimeters cubed. So our equation for number of moles of sodium hydroxide is of course mass over molar mass. Molar mass of sodium hydroxide is 40, and so 1.05 divided by 40 gives us 0.02625 moles. Our volume in decimeters cubed is 0.5 decimeters cubed, and then we pop that into our equation to find concentration, which is moles divided by our volume, and that gives us 0.025 moles per decimeter cubed. Question 3, slight change. We're going to calculate the volume now in centimeters cubed of 0.01 mole per decimeter cubed solution of hydrochloric acid that contains 1 times 10 to the minus 5 moles. So let's have a think about the equation that we're going to use. First of all, we're going to find our volume in decimeters cubed is the number of moles dissolved divided by our concentration. And so that gives us 1 times 10 to the minus 5 divided by 0.01 as our concentration, and that gives us 0.001 decimeters cubed. Convert that to centimeters cubed by times by 1,000, and that's 1 centimeters cubed. So question 4 is a little bit cheeky, bringing in gases. So they want us to calculate the volume of CO2 in decimeters cubed at room temperature and pressure required to dissolve in 300 centimeters cubed solution to give a concentration of 2.5 moles per decimeter cubed. The number of moles we need is our concentration times our volume in decimeters cubed. So that will tell us our volume, our moles of CO2 required. Our concentration, they've told us, is 2.5. Our volume is in centimeters cubed, so we have to divide it by 1,000 to convert it into decimeters cubed. That gives us moles of CO2 being 0.75 moles. And therefore our volume of gas is just our moles times 24,000 to give us 18,000 centimeters cubed of carbon dioxide gas. And since they wanted that in decimeters cubed, to convert that into decimeters cubed, you divide that by 1,000 to give 18 decimeters cubed. So I hope you found that quiz useful. It's just a little handy checkup. If there was anything you found difficult, it's always a good idea to just have a quick recap or of those videos, perhaps do a couple more questions before we move on to dealing with titrations and those calculations. If you'd like to, you can download this worksheet from the website by just following the link, and that will come through as a PDF file.